backend engineering is, in this case, it will be some value. Next we have is routing. In the previous video, we talked about different HTTP methods and how they are important in the HTTP semantic. So in a way, all these HTTP methods, they describe your intent, which we already talked about. And you can say these HTTP methods, they express the what of a request. Your intent, your action, what do you want to do on that particular resource, or what do you want to tell your server that your intention is, whether you want to fetch some data or add some data or update some data or delete some data. And the role of routing is it expresses the where of a request. Where do you want to send your intention? Where or which resource you want to perform your action or your intent on. You need to tell the server where do you want to go. For example, you have a request and the method is get, right? Your intention is fetching or getting some data from the server, and your route path or the URL path is /users, and the server sends you an array of users. Okay. So what you're saying is, I want to fetch some data. You want to fetch some data. Your action is fetching, and from where or what kind of data, right? This is the resource. This is the route, whatever you want to call it. And the combination of these two, your intention, your action, and your route, the URL parameters, the address, the server takes this and maps it to a particular handler or a set of instructions, and performs all the business logic, the database operations, and whatever is needed, and returns you the data. And to summarize it, you can say that routing is basically mapping URL parameters to a server-side logic, and that's all there is to it. And here we have our familiar Burp Suite interface, and we have a React app which we will use to demonstrate some of these routing concepts. So I'll just go ahead and fire some APIs, and then we can jump in and do some analysis. So the first request was a GET request. And if we look at the request and response, this part we are already familiar with. This is the HTTP method. This is our intent or the action we want to perform, which is get or fetching. Now this part, this is what we call the route, right? The address of our request. Where do you want to go in the server, which is in this case /API/books. Books is called a resource, and we'll learn more about resource when we study about REST API concepts. For now, we can just assume this is a route, right? And this is a route. So this is the action. This is the address we want to go to in the server, and when we send this request and the request goes through, the server responds with this data, right? Whatever the response is, it does not matter. And for the sake of this demo, we are just sending some fillers, but typically this is what happens. You send the request, the server does some kind of authentication. If it's there, then it sends the data. And then in the next request, which is a post request, here the intention is post, the HTTP method is post, the route is still the same, /API/books. The request goes through, it creates another book or whatever the resource is, and it returns all the resources again in the response, right? So if you notice here, in the previous request and in this request, this route part is the same. So what happened is, in the previous request, the request was a get method, and the route was /API/books. And in this request, it's a post method, right? And the route is still the same, /API/books. So what happens in the server is, these two things, the method and the route, these two things are kind of a key which map to a particular handler in the server, right? The server first checks what the method is, then it checks the route, and it concatenates these two and forms a unique routing logic, right? This is a unique path, and this is another unique path. These two will never clash, right? These methods, they differentiate between the two routes. And now that we know what basic routing is, we can jump into different types of routing, right? And the first two examples that we discussed, the /API/books for get and post, these kind of routing or routes are called static routes, right? And why are they called static routes? For obvious reasons, because they don't have any variable parameters inside the route. And what do I mean by variable? For example, this part /API/books, this will stay consistent. This is a constant, right? We don't have to think about a dynamic parameter inside this route. This is constant. We are always going to use this string /API/books whenever we make the request. Nothing changes in that, and it is always going to return this kind of response. That's why it's called a static route. It's a constant, or it's a particular string which never changes, and it always returns the same kind of data. So in that case, what is a dynamic route? So let's fire these two requests now. And if we look at the first one, so here if you see, the method is get and the route is /API/users /123. And in this case, this is supposed to express the ID of the user. The application of this API endpoint is, we can fetch details of a one particular user using the ID of the user inside the route parameter. And when we make this request, the server can extract this particular ID from the route path, and it can do whatever operation it wants to do, like fetching the user from the database and returning the details of the user. In this case, the server is just fetching the user ID and returning it in the response. So express that it got the user ID from the route. Since in this video, we are not going to get too much into the code, and we just want to understand the concepts behind it. But just to give you an idea, this is what the route matching part in the server looks like. The server is basically saying, let's say the handler is called route, or let's say it's called R, right? R.get. And in the matching part, it is saying it's a string /API/users /:ID. this part matches the method in the server, and this part matches the route. So the server is saying if any request with the method get and with the route /API/users, and in the next part any kind of string, right? This Solana ID, it basically means any kind of string that comes in this format routed to this handler, whatever handler is waiting to respond to that kind of route, right? So the thing to remember is this convention you'll find in any kind of service. It does not matter it's Java or Python or Node.js or Golang, Rust. It does not matter. This is just a convention you'll find. This is what I've seen the industry-wide practices, mostly colon, which says it's a dynamic parameter that the user is going to send in place of ID. The use of this is when the request comes, in our case, request was /API/users and /123. The request got routed to this part. It matched with the get, right? Where we were sending a get request. And in the next part, it matched the first /API, then the next one /users. And it's a string, right? It looks like a number, but in route parameters or in route paths, whatever number, special characters, everything is converted into a string. So this gets inserted into this slot, this dynamic parameter slot, which we are calling as ID. If you read it, it's clearly readable, right? You can read it. Like you're saying, fetch me some data because it's get, and where is that data? That is in /API/users, and whose data that is? It is of the user with ID 123, right? It's clearly readable. That's the whole idea of REST APIs, because it provides a human readable construct to routing. This is called a dynamic route, and the terminology that we use is this part is called a route parameter or path parameter. That is something to remember. We have like two different types of parameters. That's a little confusing. One is these kinds of parameters. These kinds of dynamic parameters are called path parameters because they go right after the /, right? It is part of the route. That's why they are called path parameters or route parameters. And the next one we have query params. So for this we can just type out something. Let's say some value, and let's hit this API. And if we look into this API, this is what it looks like. This is the method and this is the route, right? This whole part is the route. Basically, the route is /API/search query equals to some plus value. And now I realize this is more readable here than here. But anyway, we'll make do. So this part we understand, right? This is the route /API/search. This is the address that you want to go into the server. This is the part that server uses to match, including the method, and this route, this is the part the server uses to match it to some handler, and it performs the logic and returns some data, which is not important. The thing to focus here is the query part here, the question mark and the key and the value. This is called query parameter. That's the terminology. And next is the application. Why do we use it? Because in post requests or input requests, we have the body of the request, right? We get to use the body. And we can use the body to send some kind of data, send parameters that we want to attach into the request. We have some kind of container to send some user-defined values into the server. But in case of GET requests, in REST APIs, GET requests don't have a body. You want to send some value in the GET request. So let's say you can say that we can send those values in the path parameters, right? But path parameters serve a particular purpose, right? They serve as a semantic expression, right? In the previous request that we saw, we were saying /API/users /123, and the semantic meaning here is we want to fetch the details of a user whose ID is 123. That is the semantic expression in the path parameter. But if we want to say we want to call this API, which is /API/search, and we want to say the search value is some random value that the user has typed into the input box, how do you want to send it? Let's suppose we want to send it in the path parameter. What will it look like? /API/search and / the value. In this case, it will be some value. Technically it's possible. You can do this, but it's very hard to maintain, and it defeats the whole purpose of REST APIs, right? Providing semantic expressions to API endpoints. It defeats the whole purpose. That's why we have this concept called query parameters. In query parameters, we can send a set of key value pairs in a request. Typically, we use it with GET request because we don't have a body to send data in. So in GET request, we get this thing called query parameters, which are key value pairs that we can send to the server to send some kind of metadata about the request. For example, let's say it's a request about fetching paginated data. You want to fetch a list of books which are paginated. We have not gotten into pagination yet, but I'm pretty sure you must have encountered it at some point. They basically look like this. So let's say it's a endpoint which fetches a list of books in paginated format. So it looks something like this, /API/books. And when you hit it, the server returns an object or a JSON, and inside data, you have a list of an array of books, and it returns a set of metadata about the response, right? And it looks something like this, like total, current page, and total pages, things like this. It depends on the implementation, but something like this. So the purpose of this is, and you also have a limit here, purpose of this is the server will paginate the data, the response, and it will send a chunk of data. Let's say the limit is 20. There's some kind of default limit. So what the server will do is it will send 20 books from the start, and it will let you know how many books are there in total. Let's say 100 books, and what is the current page, which is the page 1, and what are the total pages. And if you divide 100 by 20, it will be like 5 pages, right? These are all the kinds of values you will receive from the server, and the client can use these parameters, use this response metadata to make the subsequent requests accordingly, according to the client's needs. How can it fetch the next page? In the next page, it can do /API/books, and in the query parameter, it can do page equals to 2, right? Because by default, the server sent the page 1. We did not have to send any request, any query parameter for the value of page or limit. But in the second request, we want to tell the server that we want the response for page 2. So in a GET request, we can send that information using query parameters. This is one application which will API send different kinds of parameters in the query. For example, you want to filter by some user-defined parameter. You want to sort it. What is the order you want to sort in, whether it is ascending or descending. All these kinds of information will go inside query parameters in the form of key value. So that is basically the uses and the definition of query parameters. And this is what the API typically looks like. Next we have is nested route. This is not really a type of routing. It's just a practice that you will see everywhere, because in REST APIs, for a semantic expression, we often have to resort to nesting, right? Nesting different types of resources, and the nested route is typically the result of that. And if we hit this API and want to see what it looks like, this is what the request and response looks like. So what it says is, this is the GET request, and this is the route. We can say this is the static part of the route, and this is one dynamic route parameter or path parameter, and this is the second dynamic path parameter. And the application of this is, and why do we do this? Because again, to express the semantic meaning. So what we're saying here is, we want to do a GET operation on this route, right? Let's say /API/users with the user whose ID is 123. We want to fetch the details of this user. So semantically, the first part expresses that we are fetching information or data which is related to this user. And the second part says we are again fetching the posts of that user. And to go one level deep again, you are fetching a particular post, which is the post with ID 456. We can stop at different phases here. Okay, let's see. So the first part, the static part, is /API/users. This is a static part, and this in itself is one route which we saw earlier. It returns a result, right? If you do /API/users, it will return list of all users, because that's the handler of that match is doing, right? If we go one level deep again, /API/users/123, and this is a unique route in itself, because we added a dynamic parameter, and in the server side, it will see the GET method and it will match with a different handler, right? And that handler will return the information of this user whose ID. Can stop at different phases here. Okay, let's see. So the first part, the static part, is /API/users. This is a static part, and this in itself is one route which we saw earlier. It returns a result, right? If you do /API/users, it will return list of all users, because that's the handler of that match is doing, right? If we go one level deep again, /API/users/123, and this is a unique route in itself, because we added a dynamic parameter, and in the server side, it will see the GET method and it will match with a different handler, right? And that handler will return the information of this user whose ID is 123. So this is one level of nesting. We can go further, which is /API/users/123 and /posts. And now at this point, what the server will see is it's a GET method, and it will match with a handler which returns all posts of a particular user, because we stopped here, right? And this expresses a different meaning altogether. We are fetching the posts of a user with ID 123, all the users posts, right? And in this demo, what we are doing is /API/users/123/posts/456. And what this is saying, we want to fetch data of user with ID 123. What do we want to fetch? We want to fetch the posts, and not all posts. We want to fetch a particular post with the ID 456. So for obvious reasons, this is called a nested route, right? Because we nest different types of information in different levels to express different semantic meanings, and it results in different kinds of responses, right? That's all there is to it in nested routing. It's pretty convenient, and you'll see it getting used pretty much everywhere if the API is even has a medium level of complexity. Next up, we have an interesting concept called route versioning and application. So let's just fire these two APIs and we'll jump into the concept of that. Okay. So if you look into this, so this looks pretty much like our earlier request, except it has this keyword, which is v1. It says API/v1/products. And if you look at the second request, it says v2, right? So this is called route versioning, which is a very common practice in API endpoints, servers which has a REST API interface. And the use of this is, if we look at these two requests and responses for that, you'll understand why do we use versioning in servers, right? In API endpoints. If you look at the response of this, we are saying /API/v1 products, and this is what the response looks like. It has field data and it has an array, and each array has an object, a JSON with ID name price, right? And in the second request, which is the v2 request, we have again data and we have ID title price, right? In the first one, we had ID name price. In the second one, we have ID title price. Now, it is a pretty trivial example. Usually, the use of versioning is, let's say you have an API endpoint and you are returning data in a particular format, right? And later on, new requirements came in. Let's say you were earlier serving a web app, and in the future, you were serving a React Native app, right? An Android app or a Flutter app. For that entity or that device, you had to change the response of your data. So your first option is changing the whole route, right? Changing the whole route matching part. So in the future, you are serving a React Native app, right? An Android app or a Flutter app. For that entity or that device, you had to change the response of your data. So your first option is changing the whole route, right? Changing the whole route matching part. So let's say you can say /API/new products, right? Or what you can do is you can add that to your versioning. You can say in the version 1 of our API, we were serving responses in this format and new requirements came in, and in version 2, we are serving in this format. One thing, it expresses your intention very clearly. You have the version 1 of response, your version 1 of response, and your version 2 of response. The second part is you did not have to change your whole route. You did not have to do /API/new products. Using this versioning concept, you can eventually deprecate v1. You can, let's say, send a notice to your front-end engineers that after the v2 is released, v1 is deprecated. So in the next release, all the engineers can eventually migrate to v2. So they have this window, a particular window, where they have the opportunity to migrate the request endpoints to the v2 format, and eventually you will completely get rid of v1 and you will make the v2 to v1, right? So you have a very stable and complete workflow to add new structure to your API endpoints, add breaking changes to your API endpoints using this workflow, and your engineers, your client, have a window where they have the opportunity to migrate into the new structure. That's the use of route versioning and deprecation. In the end, we have something called catch-all route. So if you hit this, and if you look at the request and response, so what we're doing here is we are sending requests to a route which the server does not serve for, right? We are doing /API/v3/products. At this point, the server does not serve responses for this route, right? It does not have a handler. It does not cater to requests coming into this endpoint. So typically what the server will do is, in the end, after serving all the different routes and all the methods associated with those routes, in the end it will do /star. Whatever request, after going through all the previous route matching algorithms, whatever request reaches here, this part, it will be mapped to a handler, and that handler will send a user-friendly message that this route which you are requesting, this route does not exist, right? This route is not found. So instead of just sending a null response, which is the default behavior if you don't do a catch-all handling, we are just sending a user-friendly message to let the client know that we don't cater to this endpoint. That's all catch-all route is about. And with that, we have covered pretty much all the concepts that one needs to know before diving deep into different kinds of routing and all the components of routing, like query parameters, path parameters, and all the nested dynamic parameters. And that's all pretty much you need to know to get into a backend code base and understand the routing parts and make changes.
So there's a reason that remote jobs are conventionally harder to get from India. The stacks are aligned against you. You could be extremely good in your skills, yet not be able to find that interview. If you're able to find that interview, there could be 10 other things that are stacked against you because you're an engineer from India. In this video, I'll talk about some of these red flags. What are these things to avoid once you get an interview, and what to do if you're trying your best to get an interview but not landing one. With that context, let's get right into the video. To preface, why would you want a remote job over an on-office job? And I think it comes down to 3 factors, especially if you're looking for a US-based remote job. Number 1, you're trying to find an offer that pays you more than 100K. Pretty much an offer that doesn't consider the fact that you're in India and your expenses are low and is purely based on skill. Number 2, staying close to your family, staying back home, which sounds like a pretty good reason. And number 3, there is a perception that if you work in a US-based remote job, there is a high probability of your technical growth to be much higher. I don't think that's necessarily true. I think there are great companies in India where your learning curve could be really high. But usually when you're working in a remote job, it's a very small team working on an extremely challenging problem. So there is a high probability of your learning curve to be really high. I think all 3 of these are pretty decent reasons for you to want a remote job. But the problem that I've seen in most people is you're not able to find that interview. I think that's the biggest place where a disconnect happens, or you don't have the right skills, in which case, even if you get an interview, nothing good is going to happen. So step number 1 is being extremely confident in your skills, making sure you know more than enough about a specific stack. What is the best way to ensure you know more than enough about a specific stack? Contribute to an open source project in that specific stack. A common question I get from time to time is, Harkirat, I have done X, Y, and Z. Is this enough for me to apply for a remote job? And the answer is, you shouldn't be looking at a certain metric. I have done X, Y, and Z, and now I should apply. I think you should be constantly contributing, constantly learning. And at some point, you'll have enough skills and enough proof of work. Randomly, this isn't a race to find the perfect stack, watch a bunch of videos on it, and apply for a job. This is a race to acquire enough skills. Lucky, you get an interview. If not, you're contributing, you can always get a standard job. The one thing I've seen in most people who do end up getting a remote job is they're not really wanting an interview today. Even if they feel like they have the right skills, they understand this is a process and are willing to hustle through a few months until they get that first interview. Now, let's say you have the right skills, you've been contributing a while, and you get that interview. The reason this path is so clear in my head is because I'm seeing too many people now who are first learning, then contributing, and then at some point are getting connected. This isn't rocket science really. I think the only thing is not having wrong expectations. Watching a few videos and covering a few stack is enough to grab an interview. Even if you get that interview, there's a high probability you'll fail. Given part 1 and 2 are sorted, you have the skills, you got the interview. I'm going to cover a few points, which is pretty much my rant anytime a student from the cohort is going for an interview. These are the points that I cover, which are mild yellow/red flags and can lead to you having the skills and having the right opportunity yet not getting selected. So please, if you do reach the stage of an interview, keep these things in mind and be pre-prepared with all of these points. Number 1, just assume they already have a bias. If you hire someone from another developing nation, let's say, Bangladesh, you will have some sort of a bias in your head, be it their accent, be it their background, be it their video camera. Whenever someone's hopping on a call and they know the engineer is from India, they will have some sort of a bias. You need to clear as much of that bias as you can. How can you do it? Please get a decent camera. I think if you have an interview, there is enough upside for you to invest in a very decent camera. I'll post one in the description. Make sure you have an HD camera. Make sure you have a decent mic, probably more than decent mic, and a very decent background. Don't have curtains lingering around. Don't make it obvious that you're sitting in your hometown home. If possible, just get a basic white background and just sit there. Amongst all 3 of these, mic is super important. They can ignore the background, they can ignore the video. Ideally, they can't ignore the video either. But let's say they do ignore the first 2. There is a very big accent gap here. Getting a good mic can help them comprehend you better, which is this person takes us to. You have to be more than decent in English. First remote will know, talk to your friends with English, all that. And that happens over time. So if you're targeting a remote job in the next 6 months, make sure of the next 6 months you're able to communicate maybe half as well as I'm communicating right now. This is a big factor. You could be the best engineer, but me very first hand, I was working at a very big company, $1 billion company, had an interview with a Chinese guy, and usually in big companies the interviewers are told you're not supposed to have any bias. But unfortunately, this was something I told my manager, it'll be very hard to communicate. My manager agreed. Yes, it doesn't matter, we're not having a bias here. It comes down to him eventually working with us and not being able to communicate. So make sure if you're thinking of going down this path, generally no next more polite. But yeah, that's pretty much it. You like to join, just give them a choice. I'm happy either way, but most probably you'll get hired as a contractor. There are no downsides to it, there are only upsides. A contractor basically means you're not officially a full-time employee, which is fine. The only downside there is you don't get insurance, which insurance is very cheap in India. You can just buy it yourself. Don't have any sort of a trauma that you're a remote contractor. It's totally fine. Doesn't matter. The money hits the bank either way. Harkirat, being a remote contractor, does it mean it's easier for them to fire me versus me being a full-time employee? Technically, yes, but you are in a remote job. 2 things happen when you're in a remote job. Number 1, if you got a remote job from India, there's a very high probability that you're the one who leaves the company and don't get laid off. Number 2, it does not matter. If they have to fire you, they'll fire you as a full-time employee as well. There is no downside to it. Don't pay taxes. Next up, salary negotiation table. So it purely depends on you. Do you have another offer? Are you currently in a cushy job? Then yes, Harkirat, the job expectations here are no offers. I'll put a screenshot here somewhere. Someone from the cohort asked, Harkirat, the job expectations here are 42k to 60k. Should I ask for 30k? I said ask for 40k. He said no, I want a job as soon as possible. I'm not taking any risk. I'll just ask for 30k US dollars. So there's a high probability he would have gotten in for 40k as well. But in the end, right now he doesn't have a job. He desperately needs one. So he's okay underpricing. I think generally this is a great strategy. For your first offer, put like some the ordinary for your first offer. If you lastly, one more big pitfall I've seen people do is use sir, ma'am, please in a conversation. If you're approaching someone, trust me, as a CTO, I don't want people who are asking for a free job. It probably just means you don't know enough coding and you'll work for free for learning. Approach people like this. Said first, focus on your skills. If charging you $1,000, self and all that usually works. There's no upside of using sir, ma'am or pleading in any form or fashion. I think companies are pretty professional. You should be the same. I think one more point this brings me to is don't approach until you've reached a certain skill level. And if you have the right skills, I think it becomes I want to do my game. Basically means whatever skills, technology, NFTs or write that code, you will be popular in the market. Similarly, find products that make a phone right behind them. So there are products that make money. Figure out what those products are. Figure out what is the tech right now behind them. I believe it could be tech, and then at some point you'll be able to get into the right skills, an on-site job, get a remote job. A lot of my friends are extremely smart and work at Google. There is no downside to an on-site job. Getting a remote job becomes a combination of having skills and hustling really hard for a long time, and fear of being rejected. I'll say this, getting the first remote offer is perform. So see, there's a very big upside. You join at a very $30K US salary. You see all your peers are making 100K. You're providing more value than them. So, you see that growth that can happen very quickly initially. One of the biggest performers in that company. I've seen this very commonly at their qualms, but Abhishek is a very good example of this. He was referred initially. They've had their qualms, but is now one of the biggest performers in that company. I've seen this very commonly in my jobs, in other, we've been sort of ingrained to do that since IIT JEE days. Leaves for a better and do that. Clear markets, then you can always hop from. Recap, what do you have to do? Number one, until you have the right set of skills, don't do anything. Just gain those skills. Make sure
What is serialization and deserialization? Okay, let's look at this. We've already discussed this, that usually we have a client. Let's say we have this client. It's a browser, all right? It's a browser. Let's say it's Chrome. And this is called frontend, right? In our typical technical language. And usually we communicate with a server that's running in your local host, or it's running somewhere remote in cloud, in AWS or GCP or Azure. Anyway, and the client communicates with the server through some means of network communication. It can be through HTTP, right? Our traditional REST API endpoints, or it can be through gRPC, or it can be through WebSocket. We have different means of communications for clients and servers to communicate with each other. For this example, and throughout this series, since we are focusing on HTTP or our traditional REST API style communication, let's assume this client is a JavaScript app. It can be React or Angular or Vue, any JavaScript framework or library. It's a JavaScript app. Usually most of the client-side apps are built with JavaScript, highly interactive apps. In order to send a request to the server, the client has to make an HTTP request, which we have already discussed in the previous videos. Looks something like this: get the URL, the HTTP, right? Some domain.com/path, something like this. Whether a GET request or if it's a POST request, we have the URL, and below we have the headers, and below that we have the request body. And this is how frontend sends the data, the request, with all the information that is required or the client wants to send to the server. This is how client sends information to the server, and the server responds with some response which the client is able to pass and make sense of. So the thing to notice here and the thing to focus here in this chapter or in this session is how clients and servers can make sense of the data that is being received or the data that is being sent. For example, in our case, the client is a JavaScript app and the server can be a Rust app, right? The web server is built with Rust language. So in JavaScript, let's say we are sending this object, right? And we have name is some string. We are sending this, and after we send this in the request body and it reaches the server, it is a Rust server. How does the server take this data and is able to make sense of it? It is able to make sense of it in its own format, in its own data types, because JavaScript and Rust have completely different data types. JavaScript is a completely dynamic language. It is not compiled. On the other side, Rust is very strict when it comes to types, and it is a compiled language. All the data types are completely different from JavaScript. So how does this happen? How one data type that is transmitted over a network is able to reach another machine that is somewhere else in the internet, and it is able to make sense of that data and perform some business logic and send some response, and the client is again able to make sense of that response and able to show some UI or perform some business logic. How does this all come together? So before we talk about data transmission over the internet, it's very good to have some knowledge about OSI model. If you're a CS student, you might have already come across it. If you're not, then you don't have to completely master it or understand every aspect of it, like IP packets or data frames, etc., etc. But having a good high-level overview or a high-level understanding of how these OSI layers, different layers of network, communicate with each other over the internet to transmit some kind of data over hardware, right? You have different types of layers called application layers and network layers, right? There are a lot of good resources in YouTube or any other platform that you can look up and just get a high-level understanding of OSI model. And going too deep into this is out of scope for this video and will probably take too much time. And people who are way better than me have explained this in a way better format. And now, assuming you have a high-level understanding of OSI models or just are aware of what this model is and how it helps make sense of data transmission over the internet. Now, the layer on top is called application layer. And after all the layers, the bottom layer is called physical layer. Or you can call it top, call it bottom, does not matter, right? These two are in the opposite end of each other, right? And the same thing happens on the server side. Here in the server, we have application layer. And the problem that we have two machines that are in different locations and they are connected over the internet, right? Let's say over the cloud. And you are asked, you have to come up with some way or some technique or some protocol, to go with the technical terminology. You have to come up with a way so that clients or one machine is able to send data to another machine, and they should be able to parse the data and make sense of it in a way that it is language agnostic. And a very obvious and common solution that you might come up with is figuring out a common standard, which is just a fancy way of saying you will come up with some set of rules and you will ask both the clients and the server to agree that this is the standard or this is the format that the client should send the data in, or the server should send the response in. So the client does what it needs to do during the execution of the session of the user, and when sending data to the server, it transforms or converts whatever the logic is from that language, let's say from JavaScript, to this standard, this format, and sends it over the network. And when receiving, the server takes the data from that standard and converts it into its own standard. Let's say it's Rust. So it converts it into a struct in Rust. And it understands the data format and whatever it needs to do. And when sending the send and receive data, and to summarize this whole thing, serialization and deserialization is basically converting to and from data to a common format, so that during transmission or storage, we'll get to the storage part, but from this example, we can say that serialization and deserialization is basically converting data from and to a common format while transmission, so that it is domain agnostic, or in this case, language agnostic, so that machines and servers and clients from different domains and different languages from different environments are able to make sense of that data and are able to respond to that data. And before we dive deep into the serialization standard, I just want to make a note here that, which I've already mentioned, that backend is a huge domain and there are a lot of technologies, hundreds of technologies that is used in the industry. So it's impossible to understand the concepts behind all of those technologies. What we will do in this video and in this whole playlist is we'll go with the most used technologies. For example, for the data transmission, there are a lot of technologies getting used. For example, HTTP and WebSockets, and we have gRPC, etc., etc. So we'll go with HTTP since REST APIs are still the most common means of communication over the internet between clients and servers. And as a backend engineer, if you are aware of and have good experience in HTTP, then you're good to. You can learn all these other technologies along the way. You just need something which is used all over the industry to get started and get some experience, and you can learn technologies as you progress over your career. In the same way, for databases, we have a lot of different types of databases. We have relational, right? We have non-relational. In relational, we have Postgres, we have MySQL, we have SQLite, right? Same way in non-relational, we have MongoDB, we have DynamoDB from AWS. A lot of different options for databases, but in this playlist, we'll go with Postgres. It's one of the most popular relational databases, and it is used by a lot of companies, and mostly the first choice these days for a lot of startups and enterprise servers. In the same way, we have different types of serialization standards. And we will go with a popular one, the one that gets used. I won't give a number, but if I had to give a number, I'll say 80% of the time, which is JSON. Is one of the most popular serialization and deserialization standards that gets used for client and server communication. We have other standards for serialization, deserialization that does not necessarily get used for HTTP communication, but definitely gets used for serialization. For example, we have YAML, we have XML, and inside serialization standards, these three, including JSON and XML, YAML, these things are called text-based serialization. Right? We have another type of serialization standard which is called binary format. And in binary format we have all again different types, and the most popular one is called protobuf. We have other formats also like AVRO, etc., etc. For serialization standards we have text-based and binary format, and inside text-based we have different types called JSON, YAML, XML. And for now we'll only focus on JSON since that's the most popular choice for HTTP-based communication between clients and servers. Now that's clear. Let's jump into JSON, and this is what a typical JSON object looks like. So to give you a little context, JSON stands for JavaScript Object Notation, and you can read more about JSON's history and its evolution from other resources. But just to give an idea, JSON from the looks of it and from the behavior looks very similar to a JavaScript object. And that's how you can understand why it's named like that, JavaScript object notation, but it is not limited to JavaScript and it is used everywhere. You will find JSON in configuration files, and of course, during HTTP REST API transmission between clients and servers, you will find JSON in log file. JSON is a very popular choice for logging application data or server data during runtime. It has a lot of use cases. For this use case, we are going to focus on HTTP transmission, of course. This is what a typical JSON looks like. In the looks of it, you can understand it's completely human readable, and that is one of the strong points of JSON. It was made to be human readable, and the data types are also pretty fundamental if you are even a little familiar with different programming concepts. For example, things to focus here is we have a starting curly braces and an end one, and all the keys are inside double quotes. So this is one rule you have to follow. The keys will be inside double quotes and they will be strings. You cannot make any other data type as a key. Keys will be inside double quotes and they will be strings, and in the value it can be a string, or it can be a number, it can be a boolean, or it can be an array, or it can be another object, right? JSON can be a nested object also. For example, let's say you have here an address field inside the same JSON. You have a column here and you can start another curly braces. Here you can write country, you can say it's a string, India, and phone number, right? Phone number, and it can be a number, something 3, 4, 5, 6, and you have to provide an ending curly braces. This is the typical structure of JSON. That's all there is to it. You won't find a lot of concepts in JSON. These are the things you have to remember. There has to be starting curly braces and ending curly braces, and the keys will have to be inside double quotes, and there will be strings, and in the value you can provide a string, a number, a boolean, or an array, or a nested object, which will again have the same characteristics of the initial object, right? There will be keys which will be inside double quotes, and there will be strings, and they will have values again in the same characteristics. So that's all you need to know about JSON. This is one of the most popular serialization standard that we use during client and server communication. So let's just see a simple demo. In fact, let's just see our earlier demo that we saw in the previous video, and this time we'll focus on the request and response format, the serialization and deserialization format, and see how it looks like. Pretty much looks like the same thing that we saw here, but let's just see in a real environment. Here we have our website interface, and this is the earlier demo that we saw in our previous video, but this time we'll hit an API and focus on the data format that gets transmitted and the data format that gets received from the client and from the server. So let's just hit the post API that was here, postbooks, and let's go to HTTP history and open this one, and let's expand this and go to the request and listen. This is a post request, and we are calling this path API / books. This is the data that we are sending. So let's just focus on the request first. Here we can see our earlier discussed JSON format. We have a curly braces, and we have all the keys that are double quoted, and those are strings, and we have a number here, and here is. If you went deep into the OSI model, so you must have come across that from application layer to it gets converted into data frames, and etc. etc. It gets converted into IP packets, and there is transmission layer, and in the end it gets converted into bits with 0101 stuff, network related stuff, right? So as a backend engineer, the thing you have to focus here is the mental model you should have is you can assume that you have this client and you have the server, right? The client has to adhere to a particular standard. Let's say this is JSON, some data again in JSON format. With respect to your knowledge of OSI model, which has different layers, which the data gets converted into different formats, from data frames to IP packets to physical bits that gets transmitted with voltage signals over optical fiber, etc., etc. The mental model to have is in application layer gets converted into JSON. As a backend engineer, that's all your responsibility is. It does not matter what format it gets converted into after this point. That is not of your concern. So it gets converted into different formats, and then in 9001, and then again it reaches the server, reaches 0101, etc., reads all the bits and does all the network related stuff. Then it again gets converted into JSON only. In the server side also, does not matter what the intermediary steps convert the data into. That does not matter. Before in the receiving end of the server, the data again gets converted into this JSON format only, and the server only gets to read the JSON. So you don't have to worry about all the intermediary steps. Now that's clear. This is the request JSON that the client sends, and the server understands this, and it takes this ID and all this information and adds it here and responds with another JSON, right? It's another JSON. So again, we have the opening curly brace, in ending curly brace, we have one key, which is an array, and each array is an object. Again, it is also in JSON format. You can see all the keys are in double quotes, and it has values in number and string formats. And this is an array, and it's received by the client, and the client understands it. And if you see here, we are rendering it here. So the client is able to receive this data from the server, and it is able to make sense of it. It is able to parse it, and it is able to render it in its own way, right? In this case, it is JavaScript, but it can be PHP also, etc. Right? This is how JSON flow looks like in client-server model. In real-life scenarios, it does not have a lot of concepts. Serialization and deserialization do not have a lot of concepts. It is a phenomena in the backend world that exists. You have to know that it exists, and JSON getting transmitted by the client to the server passing it, understanding it, making sense of it, and responding with appropriate data to the client, and again the client passing it, understanding it, making sense of it. This whole flow is called serialization and deserialization. So again, to summarize, serialization and deserialization are the techniques using which data is converted into a common format, a standard format, so that clients can send data to the server in that format, and the servers can receive the data, make sense of it, parse it, and perform the business logic, and send the data again in that common format, so that the client can again do the same thing. Serialization and deserialization are basically dealing with standard format so that data is understandable across domains and language. That's all there is to it in serialization and deserialization. And finally, my favorite topic, which is authentication and authorization. And this is probably one of those areas which we encounter every day. I'm pretty sure all of us have used authentication screens before. You have logged into different platforms, you have signed up into different platforms. Those are basically called the authentication flows. And to summarize everything in 2 sentences, authentication can be explained as a mechanism to assign an identity to a subject. to say in the technical terms, and basically to answer the question of who are you. Authentication basically means who are you in a given context. In a given context, the context can be a platform, operating system, or your phone, anything. The answer to this question, the process of finding the answer to this question is called authentication. The same way, the answer to this question, which is what can you do in that context, in that platform, in that operating system, all your capabilities, all your permissions, to say in the technical jargon, those things, the process of finding the answer of the question, what can you do in a particular context, that process is called authorization. Those are the two sentence summaries of the whole topic, and this is what we are going to talk about